What's going on, PlayDate Community? Welcome back to another episode. My name is Franchovy and we are building your game in this tutorial series. This time we're going to be making enemies that you can shoot at. I mean, you'll be able to shoot at them, but you won't be killing them just yet. But we're going to be adding collisions. We're going to be adding random movement for the enemies. So stay tuned for this few next episodes where we're going to be adding that functionality. Let's get right into it. So, what I've prepared for you guys is this little enemy right here, which looks like a ghast from Minecraft, if I'm being honest. But this is what came out of my head as I was making it. Pretty simple. It's got two animation states, so I've named it with the image table naming. You'll see it's got 20 pixels, 20 pixels. So we're gonna put this into the assets. If you want to just grab it from down below or get up to speed using the git checkout, you're gonna have to do a command something like git checkout. Sorry if you don't have the alias. Git checkout, and you're gonna say episode. Is this 9/start? If you don't have git set up, then make sure to go there. If not, the resources will be down in the comments below. So we've got our enemy. So we've got multiple things to do. So first we need to add this as an asset. So we're gonna go to assets.lua and we're gonna add enemy equals assets/enemy. Relatively simple. Next thing we're gonna do, we're gonna actually create this enemy as a class. So this enemy class is gonna be showing up this image table that we made, and we're going to add that to the screen. So it's going to be relatively straightforward. We're going to say local gfx const equals playdate.graphics. So that's our shortcut. We're going to actually also add the asset. So we're going to say local image table enemy equals, we can add a const there, equals gfx.imagetable.new, and we're going to say assets.enemy. Nice and easy. Then class open brackets enemy with capital E dot extends and gfx.sprite. So this is creating our enemy class. From this point on, we can start talking about this enemy with a capital E. We're going to define its initializer so we can pass in the image table. We're going to say function enemy, capital E as usual, colon init, open close brackets, and we're going to call the super, which is basically gfx.sprite.new, but we're going to call it as a super method, which is enemy, capital E, dot super, dot init, not colon, dot init. We're going to pass in self so that it knows what to initialize with this gfx stuff. And then we're going to say, as a second argument, image table enemy, open brackets, square brackets, and we're going to give it 1. So that tells it to use the first image from the image table. So this actually basically creates our enemy for us. And we have one more thing to do before we can put it in. We're going to go to the sprites.lua, and we're going to say import, open quotes, sprites/enemy. So we need to make sure that our file is being imported, or else we're not going to have this enemy in the rest of our game. So just to test, I'm going to go ahead and add in something inside main.lua, inside init. After all the player and particle stuff, I'm going to say test add enemy to game. So I'm going to say local enemy, lowercase e, equals enemy, capital E, open close brackets, and then I'm going to say enemy move to, and I'm going to put the center of the screen, so 200, 120, and then say enemy colon add. All right, pretty straightforward. So this should add our enemy to the screen, and as you see, we have our little Minecraft ghast over here. But it's not moving. We have two images, so let's get it moving. For that, Playdate has recently added this thing called the animation loop, which is pretty basic, but it works really well. What it does is that you give it an image table, and it basically runs a timer for you. And every time the timer gets to the delay that you set it, it will actually skip to the next image. And we can actually use that to update our sprite's image over time. So it's going to be pretty relatively simple to implement. We're going to copy and paste this core libs animation. Well, I'm being lazy, so I'm copying it, but you can do it manually. Then we're going to go to main.lua. We're going to go right above everything and go into those import statements. We're going to add one more. We're going to say import, open quotes, core libs / animation. So that imports the Lua file that Playdate Panic has defined for us, which basically lets us use loop, and there's another thing called, what's it called again? Animation called Blinker, yeah, which is nice. I mean, Blinker's great. I've used it before. We're gonna go to enemy.lua. We're gonna create this animation loop inside the class. So go to the init, we're gonna add a comment, say create animation loop. All right, I mean, I don't have much else to say there. We're gonna say self.animationLoop equals gfx.animation.loop.new. And now we're gonna pass in, so looking at the documentation to know what we're doing, we've got this gfx.animation.loop.new. We're gonna first pass in a delay. So we're gonna put in 500 there, comma, and then the second thing we have to pass through is an image table. So we have our image table. We're gonna type in image table enemy. And then the third argument, oh, my light just turned off. Hold on one second. Last thing is the should loop, and that one by default you can see here it says the value of should loop if passed or true, which doesn't sound like English to me, but it actually does sound like Lua. So if they're saying or true, that means that if you don't pass in anything and it's nil, then it's going to be nil or true, which means that it's going to be true. So we're going to not pass in that third argument because we want it to loop anyways, and by default it will loop. So the way timers work in Playdate is that they automatically start when you create them. So we don't need to start it or anything like that. We're going to go right into the update function, which is function enemy, so below the init function, colon update, open close brackets, and you can end the function there too. We're going to say self colon set image, so we're setting the sprite's image here, and we're going to say self dot animation loop dot image. No get image, just image. I'll add a comment too to make comment guy happy. Set this sprite image. So we're gonna hit restart and see whether our gas is moving. And it is. Awesome. Okay, perfect. So what we're gonna do is that we're gonna add collisions. So if I go look at my Playdate simulator here, I can actually go to Playdate at the top and show sprite collision rects. And as you see, there is not a single collision rect there, which is great. So we're gonna do this. Self colon set collision rect, and then open brackets, self colon get bounce. So I'm doing this on the player right now, inside player.lua, inside the init function, right after the move to. And let's, oh, nope, set collide rect. Okay, restart. Okay, I'm gonna go back and show sprite collision rects, and apparently there's still no collision rects. Ah, okay, so this is what I'm doing wrong. So the bounds, I think, will return where it is on the screen. So I would get, for example, you know, whatever this coordinate is, like 300, 140. And if I'm telling it to set its collision rect at 300, 140, it's actually going to be putting it like all the way on the other side of the screen. Oh, check it out. Look, it actually is right there. So you can see that the player's collision rect is being put like totally off. So what we have to do is we have to pass in 0, 0, self colon get size, open close brackets. So now you can see that the spaceship has a collision rect. which isn't perfect because it doesn't handle the rotation very well. We're going to leave it weird as it is because for now we're not going to be colliding the player. We're going to do the same thing, so you can even copy and paste that line inside bullet. So bullet colon init is going to have self colon set collide rect. And then we're going to do the same thing inside enemy, even if I do want to adjust the size on the enemy. So you can see that everything has a collide rect now. You can see that everything's got a little pink square around it. We're going to go underneath the init function. We're going to say function bullet colon collision response, and we're going to open the brackets, and we're going to say other as the argument, and then we're going to close that function, so end, and then we're going to say return, and then this is when we say what kind of collision response we want. So basically, if it's the player, we don't want to do any collision response because or else when the player is shooting the bullet, it's going to be all weird. Then if it's enemy, then we want to basically have that collision happen. You know what, guys? We actually don't need to pass in any fancy collision response, so we're going to pass in overlap as the collision response. So we're going to do return gfx.sprite. Sorry, I put that twice. K collision type overlap. So that's going to be the collision response basically for every single other entity, every other sprite. And then we're going to do inside update, we're not going to use move by, we're going to do self colon move with collisions. But basically what we want to do is we want to pass in the goal, so where we want it to go, and it's going to return to us what collisions it's run into along the way. Now, in some other instances, like if you're making a platformer, it makes a lot of sense to use collision response slide, so that basically, you know, if you hit a wall, you keep moving along that wall, and that's what move with collisions can do for you. But in our case, we're going to be overlapping everything, so everything's going to go through each other, and we're just going to be paying attention to what collisions happen. So this is how we're going to handle it. We're going to do local before the move with collision, so in the same line but before, we're going to do local underscore underscore and then collisions equals self colon move with collisions. So the underscore underscore is going to be the actual x and the actual y that the bullet ends up in, but in our case it's actually going to be the exact same position as wherever it moves with here. Oh, just seeing, we're using a velocity, so we actually need to add the existing x and y as well. So we're going to do self.x plus self.velocity x, self.y plus self.velocity y. Now we're updating the position using the velocity, which before we were doing move by, and that did it for us, but now we have to do it manually. And then we're going to go through the collision. So we're going to do for underscore comma collision in pairs collisions do. So this is the for loop syntax where you want to loop through a list, basically. I mean a table, I guess. The first thing is going to be the key, and the second thing is going to be the value. In this case, we only care about the values because it's just going to be 1, 2, 3 on the left. So we're going to do underscore comma collisions in pairs. And pairs is basically what takes a table and turns it into an iterator. So iterator means you can call it every instance of the loop and get the key value pair from it. So this is all Lua stuff. One day we'll dive deep into it and I can explain you how it works. But basically, this is your best friend, the for loop. Local other equals collision.other. And what we're going to do here, because I'm being lazy, we're just going to say print collided, so open quotes, with, and then we're going to do the next line and we're going to say print other. What that's going to do is that every time there's a collision from the bullet, it's going to say, oh, I collided with other. Now, let's see if this works. Let's run it. Press A to start. Let's go to the debug console. And as you can see, there's already collisions just based on us shooting, and it's colliding with the player, obviously. Then we can do a test where, and here you can see it's always the same table that's being collided with, which is going to be the player. Then we can shoot the mob, which you can see it returns a different table when that happens. So that's going to be when we detect the other one and we tell it, hey, You dead, brother. So let's do this. Let's hit B. Let's put a breakpoint on line 68. If you guys just want to follow along, that's okay, but I'm basically debugging now. There's no easy way to tell that this is the enemy. So that's kind of the issue that we have. What we could do is this. So check it out. I'm going to use the debug console to do this. So I'm going to say print, because you basically need to say print or eval like that if you want to use the debug console. Then I can type in whatever Lua code I want. So I'm going to say other, before saying other, I'm going to say get meta table other. And you can see that I get the meta table, which is basically the class, and I can see that it says class name enemy. So if I want to do this the Lua way, I'm going to say if get meta table other dot class name equals, so we don't need to do this class name stuff. We can use class equals enemy, then, so basically I'm just checking whether it's the enemy, then destroy, you know? So other, colon destroy. Okay, so other colon destroy. So now we're going to be calling destroy on the enemy, which means that we have to define that function on the enemy. It's going to be really easy. We're going to do it under the init function. We're going to say, so enemy.lua, we're going to say function enemy colon destroy, open close brackets, and we're going to say self colon remove. Easy. Okay, so press A to start, shoot the bullet, and we killed the enemy. Actually, we could get rid of the bullet as well. Let's just add that quickly. Self colon destroy. All right, just see if that works. Boom! You dead, brother! Okay, guys, thank you so much for watching. I hope this answered some of the collision questions, because I know that some people wanted to know about that. So please, again, post your comments in the comment section below. And in the next one, I will be handling moving this little enemy around. So, see you guys in the next one. Thank you. Bye-bye.